The Pantheon is another example of a dome system, also an arch and dome system. If you look at these little arches that are out in front of this, so this is a good example of both arch and dome. It is the oldest standing dome, and what is neat about this is you look at this, it doesn't look much like a dome, but on the inside you can clearly see this arch, and so they had to put all this extra stuff on the, get this stupid thing out of here. You have to put all this extra weight on the bottom edge here, because as that weight pushes down, then it changes its direction, it forces it outward. So all this force is going outward. If we don't have some extra weight down here, some extra mass to hold it in place, the whole thing will just smash outward and collapse outward. But with all that extra mass, if you look at this picture down here, all this extra mass and stone, then it can't expand outward because that weight of those stones are just holding it in place. So that is necessary anytime you have an arch or a dome. You have to have supports on the bottom outside edges like this to keep that arch from pushing out on the bottom. Colosseum is an amazing example of these arches, and note, just like what we were talking about before, anytime you have an arch that's on the very end, you have to have all this mass on the side to keep it from spreading out to the side. So that's why the Colosseum has these stone piles on the outside edges. On this edge, it's pushing left, but this arch is pushing right to kind of support it and balance that out. But again, the very outside one needs weight here to hold it up. So that's why the bottom, or the outside edge of all these arch rows has all that extra mass to it. Oh, they're so smart. And Rome, oh, the Great Wall of China, oh, it is the most ambitious of construction projects the world has ever seen. It spans 4,500 miles, and construction started in the 5th century BC, and it ended in the 16th century. So we're talking 2,100 years to make this thing. It's ridiculous. That's a lot of commitment, really. So 2,100 years, 4,500 miles. It was mostly constructed during the Ming Dynasty, and you can check with your history teachers on exactly when that was and more information, if you're curious. All right, looking at water supply. So the need for dependable water, once you started having all these buildings being built, then people lived in them. So we needed to have water there because people were dying of thirst. So the Romans said, okay, well, we have to find a way to get water in there. They figured out where water sources were, but the problem was it was on the other side of a valley and on the other side of a mountain. So they would have to carve through a mountain at a constant, slight, gradual declining slope. And then once they got tunneled through these mountains, then they had to get through these valleys, but they had to keep that same slope. So they had to build these aqueducts. So through series of arches, they built all these aqueducts to bring in around 180 million gallons of water every day in Rome. That's a lot of water. And Roman aqueducts were made somewhere between 300 BC and 280. For about 500 years, they were doing this kind of thing. They're just a good example of arch systems. Road systems. So the Greek had this interesting road system. Their main use for roads was if they had like religious exodus events, things like that, because they were mostly a seafaring people. What they did, though, is they put on these stones, and they had wheel ruts that were sort of either carved in or cut in over time, worn in over time. And so that's kind of what their system was. That all the width of these wheel ruts was always about the same. Romans kind of did things a little bit different. They always tried to one up in what they were doing because they wanted things to last. And so they would excavate out. They would put in sand. They'd put in these large stones called satumen, and then some rocks here. These were large flat stones. These were just kind of gravelly type rocks as rootus, and then the nucleus. This is more like sand and fine gravel. So it was just these layers, and we actually build roads fairly similarly now with these multiple layers, and we tamp them down and compact them because that prevents heaving and roads from buckling and things. And then they ended with these polygonal stones. This is kind of a bad top illustration. It makes it look very bumpy like this. You can look down here in this picture. There's these polygon type shapes, and then you had this sort of road edge, and they even had drainage ditches so that water wouldn't come in here and sort of wear this away. So the Romans really had this stuff figured out, and they have roads that 50,000 miles of roads. That's like a huge amount of road system, and it's really one of the reasons that they were so successful as an empire, because they could get troops back and forth to places so easily because they had really easy road systems to travel people around. They also have some of the earliest known bridge, and it was actually made out of wood. They did not do the stone arches because they had problems with supporting them in the water. It was fairly difficult to do that. So some of the first ones were just timber, wooden bridges. This is the Pons Sublicius. This is the Pons Sublicius, and that's pronounced correctly, in Rome. And again, it was made out of wood. Then they got more advanced. They started being able to do it with stone. And so here's a couple different examples of some stone arch bridges that were made. And these are Roman bridges in different parts of the world. One in France. Here's another one in Syria. After the fall of Rome. So we're talking from Rome somewhere around 400 or so AD to about 1750 AD. So about 1,300 years, 1,300 years, people were still using the same building techniques, still trying to make those stone everything, all these stone arches, because the Romans just had the best ways. Their roads, their bridges, everything was the best. But that's a long time. So you have to note that down. Nothing changed for 1,300 years as far as construction types went. Then people figured out ways to refine iron in ways that it could be used as structural, not just weapons and shields and things like that, but structural iron. And so the first arch bridge in the world was cast then out of iron. And this is somewhere around the 18th century. And you notice the stuff that's in between these little things, and that stuff is nothing. And nothing is lighter than stone. So that nothing made these bridges a whole lot lighter, and a lighter bridge can then span a longer distance. So that's why these arch bridges now made out of iron were able to span larger distances, and that was a good thing. Now iron rusts, and so that makes them wear down over time. So then with the development of structural steel, bridges became even stronger, became even better. So structural steel really helped with engineering. Steel contains carbon, which makes it stronger than iron alone. Steel is iron with some carbon, so it's stronger, and that's kind of why it took over. The Eiffel Tower really was the last large fully iron structure built in 1890. Empire State Building is 1931, so 40 years later, and now we're building with structural steel. But let's one up that and go to reinforced concrete. So if you put structural steel in concrete, concrete is like that post and lintel. It's like stone. It's terrible under tension. So if you try to make a concrete beam with no steel in it, it'll just collapse and crack. But if you put steel in it, steel is great under tension, but steel not as good under compression. It's still quite strong, but compared to concrete, is not as strong. So concrete with steel inside it means it's really great in compression, really strong in tension. So now we use reinforced concrete to make buildings, and we can make them taller than ever. And the Burj Khalifa is the tallest building now in the entire world. And it was in a Mission Impossible movie where Tom Cruise did some crazy stuff. They also use reinforced concrete for bridges. And so here's a bridge that's in Minneapolis. This bridge actually collapsed in 2007 in the middle of the day while people are driving on it. How terrifying is that? The old bridge did, actually. The reason for that was just because of poor maintenance. They missed the fact that some of the bolts were rusting out. Once a few of them broke off, then boom, the whole bridge collapsed. And some cars actually ended up in the river. So very terrifying experience. And to rebuild this was quite a challenge because of the cold. They had to put barges in the water that were kind of matching the current and anchoring them in there to lift pieces. So definitely a really challenging engineering feat, even really not that long ago. So bridges can still collapse if they're not maintained. That's why we need engineers that can design things well and know how to figure out maintenance for them. So that's where we're going to stop with this particular lesson. Go ahead and answer the conclusion questions, and then make sure you click share in the top right corner when you are done, and share it to my email address, and then you are good to go.